Hi, welcome to this lesson on algebra, logarithms. We're going to be looking at the logarithm laws. The first law is the power law. So, why do we call it the power law? Well, the power law says that if you take log with base b of an exponential form, a to the power x, you can essentially take out the power and put it in front here. So it becomes x times the log of base b of a number a. And we have some restrictions here. The base a must be greater than 0, but not equal to 1. And the b value must also be greater than 0. So why do we have these restrictions here? Well, if you remember the basic form of an exponential function is y equals b to the x, then this was generally, or let's say a to the x rather, this was generally of the form an increasing curve. So there's generally an increasing curve, an exponential curve, and this was when a was greater than 1. When a was between 0 and 1, then we had an exponential decay curve, where the x-axis was a asymptote for both exponential curves. So that is where these restrictions come from. A must be greater than 0. A mustn't be equals to 1, because then we just end up with the horizontal line y equals 1, because 1 to the power x is always equals to 1. So that's where those restrictions come from. B, why must that be greater than 0? So in this form here, if you have a to the power x equals b, this function a to the x here, this exponential function, can you see it's always positive? It's always above the x-axis. So that's why this output here must always be positive. And that's where those restrictions come from. So how do we know that this law works? So let's try and do a quick proof on it. So let m equal log base b to some number a. Now what does this mean mathematically? Well, we know from logarithms, this says that when you take this base b and you raise it to this exponent m, then you get this number a. So if I take the base b and I raise it to the exponent m, that is equal to a. And that's exactly what logarithms are. That is how we defined logarithms. From here, what are we going to do? Well, let's raise both sides to the power x. So I'm going to write it as a raised to the power x. And on this side will also be b to the power m raised to the power x. Why am I raising a to the power x? Well, I got an a to the power x here. So that's what I'm trying to get towards. So exponential law says you multiply these powers out. So it becomes b to the m times x. So therefore we have this expression, a to the x equals b to the mx. Now, if I take log base b on both sides, because that's what the law is saying, log base b of a to the x, by the way we define the logarithm, that'll solve this exponent for you. So this exponent mx is equal to that special number, log base b of a to the x. But what was m? M was log base ba. So we can substitute that back in here and therefore get x times log base ba. And that is exactly the power rule. All right. The next rule says that log base a of a is equals to 1. And this is the identity law. And again, the restriction is that a is greater than 0 and it cannot equals to 1 for the reasons we saw in the previous slide. Well, why is this true? Well, again, I think of what a logarithm is. The logarithm says that this base that you take here, when you raise it to this exponent on the right-hand side, must give you this number. So this base raised to that exponent must give you that number a. Well, a to the power what will give you a? That's a to the power 1. And therefore, that is why that exponent is equal to 1. So, for example, log base 2 of 2 is equal to 1. Log base a quarter of a quarter is equal to 1. As long as this a value here is the same as that a value there. All right. In the previous slide as well, if we look at an example here, if you have log base 2 of 3 to the power x, you can bring the x forward and that'll become x times log base 2 of 3. The next law is the change of base law. The change of base law says that when you take the logarithm of a base b of some argument x, that's the word, the mathematical word we use when we talk about the inside of an operator or a function, we call it the argument. It's usually that number inside the brackets. That is equal to, now you can introduce a new base a and write it as a fraction. It'll be log base a of this number inside the argument x divided by log base a of this number here, that base there, b. And again, you have your usual restrictions. Let's see why this is true. So let m equals log base b of x. Exponentially, what does this say? It says that this base here, b, when raised to this exponent m, is equal to this number x. So therefore, x is equal to base to the exponent. Right, x equals b to the m. Now, consider this fraction here, log base a of x over log base a of b. Let's substitute this x value back into there. So we log base a of b to the m over log base a to the b. Now we can use the previous law, the power law, to bring the m down. So that becomes m times log base a of b divided by log base a of b. These guys are equal, so they divide out and give you m times 1, which is m. But m was log base b of x. So look at that, log base b of x is equals to this log base a of x divided by log base a of b. And that's exactly what we wanted to show. So that is the change of base law. So as an example, if you had log base 2 of 5, you can rewrite this as log base, now it can be any new base that you introduce that's greater than 0, not equals to 1. So I can say base 3 of 5 divided by log base 3 of 2. So I've introduced a new base 3 and I've extracted these two numbers, 5 and 2. The next law is the multiplication law, and this works very similar to the exponential law for multiplication. So if you take the log of base b of a product xy, then you can separate that log into a sum of the log of base bx plus the log of base by. So let's have a quick look. If you let this log base b of x equal m, and log base a of x, or not a of x rather, log base b of y equal n, then exponentially, what does this say? It says that this base b raised to this exponent m is equal to x. So x is equal to the base b to the power m. Similarly here, the base b raised to the power n is equal to y. So y is equal to the base b to the power n. So now, if I take the product of these two guys, x times y, that is b to the m times b to the n. But exponential laws tell us that the bases are equal, so I can add the exponents. b to the m plus n. Now if I take the log of base b on both sides of xy, that is the log of base b of b to the m plus n. But I can use the power rule and take this entire power down. That's equals to m plus n times log of base b with this number left over b. Now from the identity law, we know that this guy is equals to 1. So you're just left with m plus n. But m was log base b of x, and n was log base b of y. And that proves the multiplication law. So for example, the log base 2 of 10 can be broken up into as the log base 2 of 5 times 2. And you can break that up further into the log of base 2 of 5 plus the log base 2 of 2. And we know from the identity law, this is equals to 1. So it'll be 1 plus log base 2 of 5. So that's an example of using the multiplication law. The division law is very similar to the division law of exponents, and the proof follows very similarly. If you let this log base b of x equals m, and this log base b of y equals n, then if you divide, well, not divide first, but rather rewrite this as exponential forms, then we have x equals b to the m and y equals b to the n. And then if you divide x divided by y, we have b to the m over b to the n. And exponential rules tell us that the bases b are equal, so we can subtract the exponents. And the proof follows very similarly. Take log base b both sides of x over y. That's equals to log base b of b to the m minus n. But we can bring this power m minus m down using the power rule. That becomes m minus n of log base b of b. And this guy is equals to 1. So it's m minus n. But m minus n is exactly log base bx minus log base by. So this proves that the division law works. So for example, if I take log base 3 of 12 divided by 4, you can break that up as log base 3 of 12 minus log base 3 of 4 as an example. You can go further and simplify, and we'll see those in more examples. The standard base law, not so much of a law, but more of a convention. If you have log ax like this, and there's no base indicated there, then we assume that this is base 10. All right, so for example, if I write log of 3, that is assumed to be log base 10 of 3. It's a convention just because in everyday human life, the base number system that we usually work with is in tens. The zero law says that log base b of 1 is always equal to 0, where b is greater than 0, not equals to 1. Right, so basically the log of 1 with any positive base. So how do we visualize this? Remember, log base b of 1 is equal to some exponent. So you're asking, when is b raised to some exponent equals to 1? Well, that is when you have 0, because b to the power 0 is 1. So that is why when you take log base of 1 with any base that follows those restrictions, the answer will always be 0. All right, and that'll conclude this lesson. I'll see you in the next one.